finish off our study of motion with problems when there is more than one type of motion in the same problem. So in this example, a sprinter is going to run a 100-meter dash starting from rest. He accelerates at a rate of 6 meters per second squared for 2 seconds, and then he does something different. He continues at a constant speed through the rest of the race. So when you have one of these, what you're going to have to do is split it into two parts and maybe sketch a little picture. So the entire race is going to be 100 meters. But he's going to split it into two. For the first part of the race, we're going to write down that the acceleration is 6 meters per second squared. The initial velocity is 0 because he starts from rest, so we're going to say v0 equals 0. The time for this part is 2 seconds. And then he does the second part at a constant speed. Like that. So we have to split it in two parts and treat them separately. So for the first part of the race, we don't know how far he goes or what his speed at the end is. So we can calculate each of those. So let's start out with how far he goes. So we'll use the delta x equation. Delta x is v0t plus 1/2 at squared. Delta x equals, now v0 is 0, so this part goes away. And I just get 1/2. The acceleration is 6. And the t was 2 for that part of the race. So my delta x for this is going to be 12 meters. Now I can also find his final velocity for that part of the race using this equation. V equals v0 plus at. So v equals, remember v0 is 0, so I can ignore that part of it. And a is 6. And t is 2. So his velocity is 12 meters per second at the end of that part. So I'm going to make a note of that over here, that the delta x for this part was 12, and that the velocity at the end of this part was 12. Now I have to use that for the second part. The entire race is 100 meters, so the distance for this part of the race is, he went 12 in the first part, so it's going to be 100 minus 12, which is 88 meters. We also know that the velocity right at this moment was 12, and it says that he goes at a constant speed for the rest of the race. So I know that his constant or average speed for the rest of the race is going to be 12, and I have to find the time for that part. So for that, if it's constant speed, I can use this equation. Average or constant speed is distance divided by time. So we have 12 is 88 divided by the time. And if I solve that for the time, I get a value of 7.33 seconds. And now I'm trying to find the entire time to complete the race. So in the first part of the race, it took 2 seconds. The second part, 7.33. So our total time is going to be 2 plus 7.33, which is going to give me 9.33 seconds for the entire race. So if you have something that has two different motions in the same problem, split them and treat them separately. It's just that the final velocity for the first part of the race will be the initial velocity for the second part of the race.